Hello world, today we're going to talk about machine learning. What is it and how we can use it? My name is Joseph Bonaparte, Associate Professor in Finance, and I am Director for External, do consulting for institutional companies. What is machine learning? It's a subset of artificial intelligence, develop algorithm models, and ML algorithm employs statistical technique to learn patterns and make decision and prediction. There are 4 types of machine learning: supervised machine learning, unsupervised machine learning, reinforcement learning, and deep learning. I'm going to talk about the top 3 and first, and then I'm going to go to the 4th one, deep learning, because deep learning is a mix of all of the above. How these learning models different in the type of the problem, what type, if you have a problem, what type of it. Some problems can be solved with supervised learning, some with others. Different data structure, is it labeled or not labeled, different algorithm, the feedback that you're looking, and application. I'm going to start with supervised learning. It's commonly used, controlled by the researcher for forecast, follow linear model regression or a probit model or a maximum likelihood model. It's more accurate and efficient and labeled data. You know what's your Y, you know what's your X, you regress X over Y based on the model, and you get some inference. Unsupervised learning is discover hidden pattern in the data, can be used in unlabeled data. And I will explain what does that mean, unlabeled data, like photo, images, audios, articles, tweet, or news. Reinforcement learning, it's an agent interact with the environment, creating actions and learn, discovering errors and paths. For example, if you have a vacuum in the home that remotely moves, that will be reinforcement learning. So when they walk, if they hit the chair, they will, oh, there's a chair here, they move around, but they remember there's a chair here and they go around it and move. That's example of reinforcement learning. Problem by learning type. If supervised learning, we use regression and classification. Unsupervised learning, we use association and clustering. And reinforced learning, for example, if you go here and you hit this wall, that means you cannot go, you either go back or you continue forward. And if you hit this wall, you either go back or you continue inside. And you start going all the way out till you exit the figure. I'll explain that. Type of data. For supervised learning, you have a labeled data, like income versus age. Unlabeled data, that means you have a lot of data, but you didn't know what to do with it. Is that good data? That means, should I buy this or not? And no predefined data in the reinforcement layer. Type of algorithm, linear regression, logistic. For this, unsupervised key means and C means are the most. And then the technology for reinforcement learning is SARSA and Q learning. And this is what Tesla does in the Tesla car does in their auto driving. ML applications, supervised learning, it does, for example, risk evaluation, forecast sales, unsupervised learning, recommendation system, like you should go watch a movie or not, go to the concert or not, and reinforcement, self-driving cars or gaming. Here is example for supervised learning. Suppose you want to give a loan, you are a banker, you want to decide to give a loan or not to one of your clients. So you have data about clients here, client A, B, C, D, all these clients. And then for every client, you have some data. From this, you can regress all this X's and get solution, whether this person will default or not. And then based on that, you can approve a loan or not to approve a loan, reject a loan. Another example of SL application, if you have the age of the people and their salary, so you can get an idea if you're 18 now, and you think what's going to be your income when you're 40. So you can use this data, and then there's the machine learning will tell you what's going to be your age when you're 40 or 43 or 67 or any age. So from this data, you can build a model with a forecast. Now I'm going to go to unsupervised application. Suppose there is a movie and like here's Avatar A, Pirates of the Caribbean. So there are movies and then people report they like it, don't like it, issues with the movies. but you didn't have the why. You didn't know whether they like it or not. They say, well, this is this and that about the movie. From this different data, you want to decide whether it's a popular movie or not. So unsupervised learning application, this is example, it will take this data and create for you whether it's a popular movie or not, and then you can rank it. Now, if you want to rank it, the movie based in the box office, then it's simple. You didn't need machine learning. Look to the box office. But if you want to look to other characteristics, then like the actor did very well in the movie, or sometimes you have a high box office, but the movie is not popular as much as other movies. Here's another supervised learning, and I like this a lot. If you go to Whole Food and you start buying stuff and you put them in the basket and you check out and you pay, basically, you pay how much is your basket. You think you're done. Once you get out from the store, you think you're done. No, you're not done. For you, you're done. Just go and cook and grill and have your fun. But for Whole Food, they're not done. They're going to take your data, what exactly you bought, and they're going to see if there's association. Does this person, when you have a bread, do you also buy butter? What type of butter you associate with that bread? For example, if you buy pita, what type of things you associate that? But if you buy, for example, white bread, what type of butter you buy? So they try to associate the pita with this with that. So this is association. What type of eggs you buy versus what type of bread, what type of vegetables. So they try to understand which one goes with which one. And then when you go to the shelves of Whole Food next time, they know that where they put the product, it's not random. It's based on unsupervised learning from machine learning. And finally, the one that people like it a lot, and here, because it belongs to Tesla. Tesla's example of reinforcement of learning, example, autonomous driving. So this is your car, and then you start seeing cars here, and and you cannot go because they're yellow here. So the car start moving between two yellows and to be far from the other car. So this is reinforcement of learning. There is no data here, because what if a car moves on your left now? So there is no data. You start adjust to the environment. Another example for reinforced learning, which is mowing the grass. And here you have a bad spot, for example, and then you didn't want to go there, so it go all the way, and then it doesn't get close to a spot that you don't want. So this machine learned that I'm going to go all the way till this line. Now I'm going to go jump to deep learning. And the best way to teach it is to show this figure. And you can see like this associated, like this node associated with many nodes. Look how much complicated. So if you have, and this is exactly happened in a war. Missiles interact with each other, intercept, and the helicopters and the soldiers. So there's a lot of the weather, the speed of the rocket, the first speed, the second speed in the first 2 seconds, 3 seconds. So there is multiple information. You need deep learning for the Patriot to go and intercept the aircraft or the jets or the missile. So deep learning is a subset of ML for multiple layer of neural network. Algorithm require large amount of labeled data and significant computational resources to retrain. Now, Microsoft sells a lot of cloud and Amazon to the Pentagon, but the technology that you use for the Patriot is very advanced and only for that. Now we start using very advanced technology also in our AI. So it uses weights and biases because the muscle that moves, it has biases. What the biases? Like the speed in the first 3 seconds is different than the speed in the next 3-4 seconds and the next second. So there's a lot of biases. You cannot go intercept that linear because the speed moves and the muscle moves. So you need something with different weights. Difference between ML and DL is respective to approach to learning and problem solving. That's all what I have for you for machine learning. We talked about the 3 levels and the deep learning, supervised, unsupervised, and reinforcement. We give example. I hope you enjoyed the video. I tried to make it simple for anybody to learn it. Please don't forget to like the channel, to like the video, and give us a like, give us a comment, and like the channel so we can give you more technology videos. Thank you.